Good evening, ladies and gentlemen. Again, welcome to Advisors webinars regarding the pandemic challenges. Tonight, I'm going to welcome my friend and colleague, Dr. Ibrahim Kebbe, who is joining us tonight on our week 10, forecasting investment objectives out of turbulent times. Now, as usual, before I start, I'd like to remind everyone that you can request the presentation by filling the form Mustafa is sharing, and for the PMI PDUs there is also another form. Now, again, also as usual, I'd like to thank our partners. We start with the Guild of Professionals, and then also the Strategy Implementation Institute, the PMI chapters, Moscow, Budapest, Tunisia, Central Italy, Zimbabwe, Uganda, Cote d'Ivoire, Botswana, and Mauritius. As well, I'm happy today because we now have a new partner. We signed with Irina, Mr. Ahmad Abdel Salam from Tunisia. He is now our partner there. So I'd like also to welcome them to Advisors, the group and alliance. As I said before, we have a very interesting announcement because now we became part of, we are the newest associate member of the GDA, Gulf Downstream Association. But I'm gonna speak about this in more detail later on. The next thing to do is to introduce my colleague and friend before I put the camera on him. Dr. Ibrahim Kebbe, he actually is PMP and RMP certified. His PhD is in Advanced Complex Systems from the Imperial University of Japan, or Hokkaido University. We studied together at the American University of Beirut. We met in 1986 in the engineering school. Then he continued to do his master's, I believe, in solar energy. And then he got the opportunity to continue his PhD in Japan. Afterwards, he came back and he worked at several universities and as well in the business of consulting and training. His main focus is business analytics. His passion and business is business analytics. So, having said that, I'd like to welcome Ibrahim. Now, Dr. Kebbe is with me in the room, so I'm just going to pass the camera to his side. Dr. Kebbe, good evening. Good evening. Welcome, and the floor is yours.
Thank you. Well, good evening, everyone.
I hope you do enjoy this session because it's a very interesting subject to me personally. And despite the fact that I started from engineering, I have a lot of contact with business since I was solicited into business school some 20 years ago. So let me start with the table of content. As you can see from the presentation here, we have 5 parts. We have a prologue that starts the story of this webinar. Then we are going to talk about forecasting and the methods. Then we are going to go into the epilogue, the result of what happened in the first story. Then we are going to deal with disruption. That's to say, the techniques of forecasting by using qualitative forecasting. So, without further ado, let's see this magic. Some 26 years ago, a company in the United States which is specialized in mega machines in earth movers. This machine, this company actually was thinking about revamping their baseline. Okay? Meaning that they need to change their whole production line into new products, following the feedback that they have had and the experience in maintenance and repairs that they've had along the years, which is something natural. I mean, 25 years of the same line would be too much. So what they did was they came together, the board of directors, and they set up three objectives. They wanted to, optimize. First, they thought about the dividends. Let's say their bottom line. Okay. Okay. It is off. So, what now?
Proceed on.
Okay. So these are the three objectives that they have had. The bottom line. The shareholders need to.
Dr. Kebbe, can you please redo this introduction because we just have the echo problem.
Yes. I was talking about in the prologue about a company that produces earth movers, mega machines that are mainly concentrated in strip mining and such industries. So obviously their machines are not standard machines that you can see. As you can see from the picture over here, this is the Komatsu earth mover. So you can see how small the guy is next to the wheel. So these machines have been around for more than 25 years, and they were thinking about revamping the production line. So by doing so, they needed to conceive the they needed to conceive these matters on three objectives mainly. First of all, the bottom line, the dividends, meaning that they need their shareholders to obtain maximum amount for the shares so that they may remain interested in the company. The next thing is that they don't want to go thin on their costs. Otherwise, their credits are going to be extended thin within financial institutes. So they needed to cut down on costs as well. And last but not least, they needed to stabilize their human resources in the sense that their human resources are actually specialized human resources, specialized labor. And specialized laborers are very hard to find. I mean, this is the type of experience that you cannot find in any other company. So what they did was they said that, okay, we need to maximize our dividends, we need to minimize our costs, and we need to stabilize, that is to say, we need to keep our human resources constant. I believe they've had about 4,000, around 4,000 workers in their factories. So, this problem seemed to be a classical problem of optimization. So they said, okay, we have three objectives, and obviously they are conflicting. So what we need to do is we need to set up some kind of compromise. The technical word for that is goal programming. They would like to treat these three objectives as three different goals, and they would like to set up some priority between these goals to see which ones are actually more important than others. So what they did was they went along, they did their homework, okay? They did their homework, and they came up with a formula, if you will, and they went on to apply it. Now, we have the first poll. Okay, can we go? So these are the compromises we were talking about. What do you think that would be the solution to their eminent problem? Which, remember that this is the problem of optimization. It's an optimization problem to start with. Okay. I think we have stability now. Okay. So, as you realize, most of the answers were to prioritize our compromises. Obviously, we have three different and opposing objectives. So, in order to be able to, not to get sidetracked by any one of these, all right, we need to actually set up what kind of priority we have. In terms of soft constraints, we need to set a certain goal related to the dividends, the shareholders' dividends, so as not to go below a certain ceiling. Okay. And on the other hand, not to go above a certain floor to the costs. Okay. On the other hand, we need to more or less stabilize the human resources. By the end of the day, the solution to that problem was that they could have actually stabilized the first two conditions, okay, the soft conditions, but they had to actually hire new workers. Actually, they hired, if I remember well, 122 laborers, so above the 4,000. Okay, so this is the obvious or the apparent solution to their problem. Okay, so they went on beyond planning, and then we start our forecasting definition. Let us define what is forecasting. Forecasting is the art and science of predicting the future events. This is basically what forecasting is. It is not only a science, it is also an art, which actually leaves way to qualitative methods in forecasting. The second thing is, where do we apply forecasting? Where is the application of forecasting? Well, forecasting is applied in many industries. First of all, let us talk about the horizons of the application. You have short-term, medium-term, and long-term forecasting. Short-term forecasting is typically somewhere within 3 months. So if you have a problem in which you want to forecast some value, all right, and that value will actually serve you within the coming 3 months. So you resort to what we call short-term forecasting. Short-term forecasting is typically quantitative. It is typically quantitative, and it is fairly precise. Then you have the medium term. You have the medium-term forecasting. Medium-term forecasting is somewhere between 3 months and up to 3 years. Obviously, it is not as accurate as short-term, but it is nevertheless very important, and it has many types of methodologies that are related to it. It's much more versatile than the short-term. The long-term, the long-term forecasting is typically qualitative. Sometimes quantitative, but usually qualitative. It is long-term, has a long range of time, which goes above 3 years. All right. The application, the areas of application here are, we have 3 main application areas for forecasting. You have economical applications, you have technology applications, and you have demand applications. In terms of the economy applications, an example of that would be the determination of the economical business cycles, whether these business cycles are related to finance, like for example, the business cycles related to futures and the stock market and stuff like that, or, for example, something that has to do with the economical health of a certain country, like inflation rates. Inflation rates are tricky to forecast, and it depends, of course, on what kind of term we are looking at. So, for example, if we go beyond the short term, the inflation rate becomes very risky in terms of the quality of the forecast. We will get to that shortly. The second type of forecasting is predominantly qualitative, which is the technology forecast. For example, technological progress or the viability of technology products. Like you've probably heard of some technologies that went like a flash in the pan, like the zip drive, if anybody remembers that, or the MO drive, made famous by Tom Cruise in Mission Impossible, the first part. Anyway, then, these products have actually disappeared overnight because of, because the forecasts were not made that precisely, or they were biased to begin with. And then you also have matters related to equipment or the line of technologies. For example, if you want to introduce the 8K, if you want to introduce the 8K technology, for example, you need to have it integrated across the whole supply chain or the whole line of products. Like, for example, to start with, the capture technology. I would like to have an 8K capture technology, which is actually, cameras. And these cameras have actually started out from a surgical need. It's of surgical need. But so far, 8K televisions, which actually figure at the end of that spectrum, are not that common. So these things need to be meticulously forecasted. And obviously, this is something which is done qualitatively, as we are going to see later. And finally, you have the most popular area of application for forecast, which is the forecasting demands. For example, forecasting the demand in terms of sales, because demand and sales are there are a bit a small affinity between these two terms. And sometimes they are used as one, sometimes they are different from one another. Anyways, this is, as I said, something which is very very popular. So now, after talking about these application areas, I would like to ask you something which is related to our bread and butter, as they say. What about forecasting applied to project management? Okay, where do we find forecasting in project management? I guess most of you are actually well versed in the culture and knowledge of project management. So it has nothing to do with it. Nothing. It is something that we only see in earned value management. It is something that has to do with quality control process, the process called control quality, or the process called closed project or phase process. Which is which? I see somebody has been studying. Okay. Okay, I can understand that as well. Okay, so if we look at the answers, the vast majority agreed that there has to be something about forecasting found in project management. A simple search in the PDF will actually show you that, the PMBOK 6. The vast majority, 76%, talked about finding it in earned value management. And this is correct. In control quality process, well, quality actually is something that hinges on the past. It is something that hinges on the past. In terms of quality, if you're not talking about quality assessment, because in this case, in quality assessment, you are looking at the elements that would help us have better quality in the future. But all of that is actually residing on doing some forecasting based on, data from the past. Now, most of the application in forecasting is found in earned value management, precisely in the place where you find a certain distinction between typical and atypical behaviors of expenditure or time. So it is typical if that phenomenon, whether it is an overrun or an underrun, or lateness or early behavior or of time. In earned value management, we talk about doing forecasting when we mention the fact that we have a typical behavior. Atypical means that it won't repeat itself. So for example, if within the first quarter of the project, you have made, or the first quarter of the earned value of the project, you have actually made a saving of $10,000. It is atypical if that savings is not supposed to be repeated. Yani your basic assumption is that it's not going to repeat itself. Otherwise, if it is typical, it means that you expect every quarter, the second, the third, and fourth quarter, you expect that this is going to repeat itself. So in this case, it is typical, and it actually affects the way, it affects the way you project on the progress of the project. This is the thing. So what you're doing here basically is the most basic type of forecasting. The most basic type of the forecast. So for example, the typical forecast, we call it the naive method. This is the most basic method in forecasting, in quantitative forecasting. Whereas the atypical is called the once in a lifetime thing, or the disruption, the once in a project disruption. So as I said, these are the two extremes of a large spectrum of forecasting techniques. Earned value management only touches on the subject; it doesn't actually go deeper than that. So, what are the characteristics of quality in terms of forecasting? The characteristics of quality. First of all, you need to have a good forecast. It's basically three things. It is a timely forecast in the sense that it is updated regularly. The second most important aspect is the aspect of accuracy, which is the loss or the absence of bias. Your forecast shouldn't be biased, whether this bias is related to the personality of the forecaster or the environment of forecasting. The third one, and this is also very important, is reliability. Reliability is how close the values or how consistent the values of forecasting are being displayed one period of time after the other. Because you can imagine that forecasting is an ongoing effort. It's an ongoing endeavor. So this endeavor had better be reliable in the sense that we don't have much dispersion. We don't have much dispersion related to the results of the forecast. The rest, you can see that there are 5 other elements of quality. You have, for example, technological elements that are the online capability and the compatibility with the database systems. Nowadays, this is something which is very important. This is an element of these capabilities are elements of communication, which is very important. They need to be your forecast need to be distributed across a database system, and that database system should have online capabilities. On the other hand, you have representation conditions or representation quality. No forecast will actually be taken into consideration unless it is written in meaningful units That is to say, units that are consistent all the way, and they are easy to use, and they are also easy to understand. For example, in the place where you should make a distinction between demand and sales, it should be made so, because one of the most important areas of application, and this is very critical because of the cost related, is operations management. Whenever you think about operations management, the first thing that comes in your mind is actually capacity. You want to plan capacity according to the design of the product that you have on one hand, on the other hand, on the potential demand. So this is why it's always easier and the safest bet to start with demand and then go from there to continue with the design. Now, as we have seen the characteristics of quality, okay, we now go to the process of forecasting. As you can see from this graphic is more or less related to the process by which you work on your forecast. So first of all, you start with tidying up your data. You can see from here, first of all, we determine the use of the forecast. That's to say, what is the objective use of the forecast? Let's say, for example, I want to use my forecast in order to, let's say, for example, I'm constructing a house of quality. And house of quality is a very important tool that is used in operations as well as some of the phases of project management. So in that house of quality, I want to, let's say, determine what kind of capacity I need to have in my lines of production. So I've already determined where I want to use my forecasts. Let's say, for example, I'm forecasting demand, and this is where I want to use it. So the next step would be to select the items to be forecasted. Okay, what kind of items do I need for forecasting? That's to say, what are the characteristics? It's not only necessarily the demand. It might also be the focused demand, in the sense that I would like to know something about the demand, and I would like to also to connect that to the pricing that I want to have. So we are here talking about two different things that we would like to decide upon. Okay, the difference is, in terms of decision sciences, is that pricing is something that you determine. All right, this is a choice if you want, or an alternative, an option. On the other hand, the demand is not your concern. It's not something that you can directly control. I mean, it's environmental and organic. You cannot control it directly, but what you can do is you can influence it, let's say by the function of marketing, and you are capable of having an idea about demand by using your past experience. I mean, after all, this is what forecasting is all about. Then third, you need to determine the time horizon, as we mentioned before: long-term, short-term, medium. After that, you need to select what model you need to use for forecasting. The model that is used for forecasting is related to the item that is being selected for forecasting, as well as the second and third point, and the time horizon. All right. Based on that, you select your forecasting method, and then you collect all the data, all the historical data that you need to make your forecast. And of course, the data by itself, if you look at the graphic here, you will realize you need to visualize. Nothing can be done, whether we are forecasting or we are doing anything that has to do with data, nothing can be done without first having a look at how the data plots. You cannot do anything before visualizing the data, because it's going to give you ideas, and it's going also to affect, in terms of feedback, it's going to affect the model selection process. And finally, you make your forecast, and of course, after doing the forecast, okay, you have your results, you implement them, and after implementation, this is the last step. After implementation, you make feedback on that. You make some kind of control.
over your forecast. Okay. So validate and implement your results. Here, validate means that you control your, in the simplest terms, controlling your results would mean to wait until that result becomes a historical fact, and then compare it with with the forecast that you have done before. This will actually give you an idea where you are going you're going over later, because as I said before, it is an ongoing process. Forecasting is an ongoing process. The next slide shows the categories of the models that we mentioned. We mentioned something about models of forecasting. As you can see from the graphic here, forecasting methods are divided into two main parts. You have the quantitative methods and you have the qualitative methods. In this chart, the qualitative methods are not they are not fully explained in terms of options that you have. It simply says market research. Well, market research is nice, okay, but of course we will see some other details later on. If we concentrate on quantitative methods, and these are very popular indeed, these quantitative methods are divided into two parts. Causal methods, okay? Causal methods, methods that relate to cause and effect on one hand. On the other hand, you have the time series methods. You can see what we have here. In terms of causal methods, you have regression analysis, linear, nonlinear, simple, and multiple. Linear and nonlinear means that there is a linear or a nonlinear relationship between the x's and the y's, the causes and the effects. Okay. On the other hand, it could be simple, meaning one x against one y, one cause against one effect, or it could be multiple causes against a single effect or multiple effects. It goes, goes without saying. This is the causal methods. On the other hand, you have the time series methods. As you can see, we have multiple methods that we are going to discuss later on, the merits of each one of these, what each one of these means, all right? When we look at the behavior of the time series, what is the main difference between a time series, okay, and a, the causal methods, okay? It's about, okay. Okay. Imagine this. You have a plot of data, all right? You have a plot of data. And this data is, for example, representing the prices of the on the stock market, certain stock in the stock market across time. Obviously, this is called the time series. Why? Because in this case, the x-axis is the axis of time on one hand. On the other hand, if you look at the data points, you would realize that the only dependency here of the data here, if you consider, for example, the level of the data point, for example, the level of the stock, if you consider that to be the y-axis, the x-axis being the time, and the y-axis being the price of the stock, you would wonder, what is the relationship between time, all right, and the price of the stock? Obviously, there is no relationship. The only relationship that exists here is the relationship of autocorrelation, in the sense that the data is autocorrelated, meaning every data point is actually dependent on the one before it. So it means, in plain English, that the price of the stock today is caused and influenced by its price yesterday, and so on. So it means that today's price is significantly affected by its price yesterday, if you are talking about daily prices, and that same price of today is more or less dependent on the price of the day before yesterday. So this is called autocorrelation. Why do we resort to autocorrelation? Because on one hand, we realize that time is not the actual independent variable on one hand. Obviously, time is not the actual variable. On the other hand, there are actual causes to the level of the stock displaying this way. But our problem is that we don't know that causality. Something is causing it, but we don't know it. So we treat it as a black box. We treat it as a black box in terms of the time series method. Okay? So in time series method, quantitative methods, we rely on the behavior of the data points rather on their connection with other, other values. However, in causal methods, okay, we directly connect the value of the y-axis to the independent values. Okay. And the next slide, we see how the forecasting is positioned with respect to PSDM. That's to say, problem solving and decision making. Problem solving and decision making. We realize that we have three categories of models or problem solving methods. We start first from standard reporting, which is descriptive. This is or data querying or data visualization, and even descriptive statistics. All of these, and even data mining. In some way, data mining is considered to be, descriptive. What do we mean by descriptive? Descriptive means that we describe the relationship between data points, or between certain data points and certain other phenomena. We relate the phenomena together. This can be done by standard reporting, by data querying, data visualization, or descriptive, even descriptive statistics. But with this in mind, okay, what value we have from descriptive methods? The only value that we have here is the explanatory value. We can actually explain the behavior, okay, relate the behavior of certain variables to others. For example, how demand is affected by the season. How demand is affected by the season. This is something which is descriptive. It actually describes the effect of season on our demand. Later on, if we move along, you realize that there is some kind of overlap between predictive and descriptive methods or analytics. Data mining and forecasting are considered to be predictive, okay? Whereas data mining can be either predictive or descriptive, okay? But forecasting by itself and predictive modeling are considered to be predictive, meaning that we are actually trying to predict future values, okay? Now, once you have done that, you go into the realm of prescriptive studies, of prescriptive analytics, in the sense that you either apply a certain simulation, some rule-based models, some decision analysis models, and finally optimization, which is the highest level of analytics. How do all these relate together? Simply put, descriptive and predictive methods are actually in the service of prescriptive methods. Let me give you a very simple example. First of all, you have, let's say that you have, for example, a certain decision context, a problem of decision making, where you have your decision on price, your option on pricing a certain product, and how much you are going to produce, your production capacity needs to be based on what? Needs to be based on the on demand, for example. So if you look at demand, first of all, you have a descriptive relationship between the variables. It means that with a certain, for example, with a certain raw material and labor and you connect all these elements to what? To the finished product. So what you have is what? It's a descriptive pattern. It's a descriptive element. On the other hand, you obviously need some parameters, that are necessary to solve your problem. The parameter of pricing, the parameter of price, let's say, and the parameter, for example, of demand. When you put these two together, the description that you have of the problem and the values, the predicted values of the otherwise unknown or ambiguous parameters, you put them together. Now you are able to do what? Now you are able to apply descriptive methodologies, meaning that you can actually optimize. Okay, you can actually optimize your production based on the first two steps. So this is how it evolves in terms of methodology. Now, in terms of, if we look at the next graphic, we look at the knowledge areas.
Can you give an example on the rule-based models?
Yes, the rule-based models are a kind of heuristic methodology which is actually based on rules. Let me give you an example. Let's say that you have for example, that you have a certain value, okay? You have a certain value that needs to be minimized, let's say, okay? Minimization has, or optimization in general, you have more than one model to actually handle them. You have linear programming, you have meta-heuristics and stuff like that. But the rule-based models are the simplest of all these models. Usually, rule-based models are displayed in terms of rules, and these rules are usually taken from data mining. For example, in data mining, you have, for example, clustering, which relates certain characteristics of certain transactions to the, let's say, the customers of these transactions. So the rule-based model would be something like a recommender system. An example of that would be what you find in the recommender systems that are actually part of AWS, the Amazon Web Services. If you go, for example, buy something from Amazon, let's say you buy a certain product, all right? The next time you go into that Amazon website, it automatically recognizes you because of your of cookies, all right? And it starts suggesting similar products to you. So this is done by rule-based modeling. Now, in terms of the knowledge areas, because knowledge areas are a big thing in project management, it's also a big thing in analytics. If you look, you realize that we have three, if you want, pure areas, not hybridized. We have three pure areas. You have the decision-making area, which is basically based on psychology, behavioral sciences, and even economy. All right, because by the end of the day, economy is something like business. It is a social science. Project management is social science as well. So this is one circle. This is one knowledge area, pure knowledge area. The other pure knowledge area is technology. Technology that is taken from computational systems, from electrical engineering, communications engineering, and stuff like that. Yeah, basically all the computing baseline. When these two are collected together, the intersection between them is our information systems. Systems that are made to support a certain business by using, for example, databases, by using ERPs and stuff like that. So we call these, the intersection information systems. On the other hand, we have a third knowledge area, pure knowledge area, which are quantitative methods. These quantitative methods are rooted in mathematics, statistics, and econometrics. Econometrics is like the statistical applications in economics. So this pure area is largely based on applied mathematics, if you will, okay, and statistics. When this knowledge area interacts with decision making, we are talking about operations research or operational research, which is concerned mainly with what? Mainly with optimization and dealing with stochastic systems that contain risk. On the other, so this hybrid connection between decision-making and quantitative methods is called the business or the business-centric analytics. These are the business-centric or problem-centric analytics. On the other hand, the connection between technology and quantitative methods would actually give rise to artificial intelligence, especially machine learning. So machine learning is a way to apply computational sciences in order to, operationalize the quantitative methods. An example of that would be, for example, deep learning systems or artificial neural networks and genetic algorithms and stuff like that. So all of these are also called analytics, but these are not business-centric analytics. These are data-centric analytics. As you can imagine, it's very hard to collect both of these together. So people so far choose to keep these two separate, keeping these two separate. The pinnacle of the combination would be analytics. And analytics is all about the futures. So where does the forecasting effort resides? It actually resides in analytics. Okay. The next slide talks about the quantitative forecasting. So let us start with data with time series. We've already mentioned what is an autocorrelated data, and there is a simple test that you can do. You can Google it if you want. There is a simple test that you can do that will actually tell you whether or not this data is autocorrelated. All right. Now, as I said before, the next point is showing that the autocorrelated data, the way it actually treated, each data point is dependent. We've already mentioned that, yes. And we said that the causes are actually black box. We are not concerned about the causes anymore. What we are concerned about is the behavior of the data. Okay? So the behavior of the data. If you look at the properties of the data, as you can see, first of all, from the graph down there, what you see is historical data up to 36 months. That's 3 years, roughly 3 years. What we're trying to do is we're trying to forecast the 4th year. If you see the data points here, okay, the data points here are 48 months. The data points that you see are 48 months. So these 48 months, the first 3 years are actually history. All right. So what you did was to do a time series forecast. You consider this data to be time series, and for good reasons that we are going to explain now. You consider them to be data time series, and you've treated them as such. What you did was you stripped them of certain properties in order to be able to extend them safely into the future, which is the next year, and the 4th year. But if we look at the characteristic of this data, you will realize that we have 6 characteristics. All right. Let's see. The first characteristic is the level. Plainly said, the level of the data is simply the average of the data. That's it. The line of average of the data. If you realize that, if you, for example, display your data, you don't even have to go through, through any statistical analysis. If you plot the data, right, and then you plot the line that shows the average of the data, and look at it and realize that there is a balanced dispersion about the average, then in this case we say that our data is level. And the only thing which is left to do is employ certain approaches in order to be able to find what that level is. I'll give you a very simple example. Let's say that there is a certain growth pattern related to a certain company, the growth pattern in sales. You plot the data, you realize that the data has an average, and that the growth patterns are actually bubbling about, up and down that average. So what you want to do is you would like to find that average and say, okay, within the next year, we expect to have an average, okay, growth, which is equal to the average growth in the first year. So in this case, for example, we can apply many approaches, like the naive approaches. The naive approach that we've already seen in what? We've already seen in those cheap weather forecasts, where they tell you the weather today was that much, so today is going to be the same. Come tomorrow, so tomorrow is going to be the same. Come tomorrow, they will tell you, well, for example, let's say they would say tomorrow it's going to be the height of the weather is going to be let's say 26 degrees. Why? Simply because yesterday was 26. Come next day, they'll say, tomorrow is going to be 28. Why? Because today it turned out to be 28. So naive approach, this is called the naive approach. You have the smoothing, moving average, weighted moving average, exponential smoothing. All of that are related in dampening, dampening the data in order to find out that level. The next level or the next characteristic is the trend. Trend, we try to see whether the data is positively trending or negatively trending. Well, let's say whether it is increasing or decreasing. We do realize that when we have the plot of the data, right? So what we find, when we find data such as that, we employ a method which takes into consideration trend-adjusted smoothing. Yeah, it smooths the data. Once it does that, it actually shows you a certain trend that you can extend into the future and base your forecast on. Then you have seasonality. Seasonality is when you have changes in the data that occurs periodically. Like what? Like Monday has the highest traffic rate. Every Monday is going to be the highest. So you realize that there is some kind of seasonality happening all the time. And another example of that would be the industry that is based, selling gifts. Gifts are also related to which quarter of the year you are in. Obviously, the fourth quarter shows the highest sales in gifts. So in order to work on seasonality, we use what we call the seasonal relatives. Cycling means it is related to business cycles, and this is something which is extended. It happens over a very long time and requires a lot of stability. This is why you can't find cycling, for example, in the stock market, in the American stock market, to be exact. Irregularity, it means that something that you can move or remove affordably. And finally, you have the randomness. You can do nothing about randomness. It's very random. So what you need to do is just clear it out because it's noise. It's something that you cannot relate to. So what is the difference between cycles and seasons? This is my next point. Are they the same? Or seasons are shorter than cycles? Seasons are regular intervals, whereas cycles are not regular, or seasons are periodical, whereas cycles are not periodical. So let's see what the answer is. Okay, so we have, seasons are shorter than cycles. Well, not necessarily. I'll give you an example. Cycles, for example, if you have a cycle that repeats, for example, within 2 years, 3 years, seasons are not necessarily shorter than cycles. For example, the Olympics. The main Olympics are occurring every 4 years. So this is considered to be seasonality because it happens on a regular basis. The actual answer is that seasons occur on regular intervals. They are regulated regularly, okay? Whereas cycles, you cannot have 2 business cycles of the same length. It doesn't happen. This is like sleep cycles as well. They don't occur on, on regular intervals. Okay, now, the other type is causal methods. The other type of forecasting is causal methods when you actually realize that there is a relationship between certain independent variables and the dependent variable. In which case, you are doing associative analysis. And mainly what you're doing here is you are employing regression. Okay, you are employing regression. So we realize that the independent variables are actually influencing the dependent ones, and we would like to see what kind of influence we have in this case, what kind of influence we have. So it could be a linear or a nonlinear influence. For example, in market saturation methods, obviously we work on nonlinear regression, exponential or what we call survival curves. Okay, but my next poll is this: how different is regression from clustering? We mentioned something about clustering when I mentioned the matter of data mining, data mining for transactions and recommender systems. Okay, recommender systems heavily rely on clustering technology. So what's the difference between regression and clustering? Regression predicts, whereas clustering classifies. Regression elaborates the future, whereas clustering classifies, elaborates the past. They're the same. Regression is quantitative, clustering is qualitative, which let's Okay. Let me address this issue. Most of you have said that regression is quantitative, whereas clustering is qualitative. First of all, quantitative is not the same as numerical, all right? When we say that we have a numerical method, that numerical method might even cover what qualitative aspects. They might have qualitative aspects. In that spirit, I would say that regression can be quantitative with a hint of quality in it. I'll give you an example. For example, you want to make a regression to see what is the dependency between years of experience, being the independent variable, and the salary. And you add another qualitative element to it, which is the gender. So it means that we are dealing here with three variables. We have the salary, the years of experience, obviously quantitative both, and then we have a qualitative matter that comes into the regression, which is the gender. So in this case, we can actually have so regression is quantitative, but it can have a qualitative element in it, discerning the levels, the different levels of income, all right, between men and women. On the other hand, clustering is basically qualitative, but it could contain an element of quantity. The correct answer is that regression predicts predicts, whereas clustering classifies. In clustering, you actually want to classify your customers. This is what you do, for example. Classifying transactions means that you are actually classifying your customers in order to, for example, offer them by name, that's to say, offer them a special offer. Okay. So, moving on, after the end of all that, what about the quality of forecasting? How do we guarantee the quality of forecasting? Well, the quality of forecasting is based on accuracy and, as we said before, accuracy and precision. Accuracy shows how big is the error of your predictions by comparing the actual data with the previously predicted data. So we use these three measures, the MAD, the MSE, and the MAP, whereas in the precision, there is one very popular KPI that we do is that we use that's called the tracking signal. The tracking signal shows you what kind of consistency your data has. If these tracking signals come out like 1, 2, 3, 4, 5, it means that you are having a good consistency that is your forecasts are actually reliable. So this is how you guarantee your forecasting quality. Now, let's go back to our friends from the heavy equipment company. Okay. After all these compromises were done, you remember that we talked about this problem. Failure was the result. The line, the prototypes of the new mega machines didn't sell well. They went wrong. What actually went wrong? So what do you think? What do you think actually went wrong? The compromises were not enough. There were other compromises that needed to be used. The historical sales data were not dependable. The seasonal timing was off. They did something wrong within the season, or mega machines are not popular anymore. So, what would be the matter here? Good. Okay, so as you could have guessed, historical data, sales data were not dependable. Why? This is a line that has lasted for a quarter century. Obviously, when you want to move to another line, you have to forget about your old data. Your old data is not valid anymore. Your history is not valid anymore. The industry has changed. Your customers has changed. New customers have, risen up the ranks. So it means that here we have a disruption. What went wrong with their decision is that they considered to be an optimization problem, where they didn't actually get the correct elements, that's to say the correct parameters to start a problem, such a problem, let's say the prescriptive or optimization problem. They needed to have had a better. What is the solution to this problem? The only solution is in the third option that we have on forecasting methods, that is to say the qualitative methods. When we talk about qualitative methods in forecasting, we are mainly talking about surveying or market research. So if we look at this market research, all right, the qualitative, so we have four main sources or methodologies in order to deal with that. First of all, we have the executive opinions. This is highly objective, subjective, and it is residing within a jury of executive opinion. That's to say, the middle to upper managers, the C-level managers, they have to, they have to come up with their view of the future. This is one side of it. The other side is the sales force opinion. Your salespersons, the people that are dealing with the sales in the field, they need to be polled for their own opinion about the things that could happen in the future. What do we need in the future? The third point would be, or the third methodology would be the consumer survey. Do a market survey on your end consumer. See what your end consumer wishes, because at the end of the day, it is the needs of that very consumer that actually dictates, the sales of the future. And last but not least, you have the Delphi or the Delphi method. And that method has actually been used in the 70s when Microsoft, if I remember well, did a survey, the Delphi method survey. They collected, experts, and they wanted to actually forecast the future of, believe it or not, colored monitors, as opposed to monochrome monitors. The future of colored monitors in the market, in the computer market. Well, that method was very much reliable in getting the trends for the future. Because the bottom line is that all your data from the past, all your history data is not valid anymore, cannot be used. No matter how creative you come with the methodology of forecasting as such, it's a very, very long shot in the dark, if you want. So, in conclusion, when you want to have optimized decision making, you need to combine ways of qualitative forecasting and quantitative forecasting methodologies. The quantitative forecasting, the qualitative forecasting is done on the, these ways are done on the macro level, the high level of market research. It is done, for example, qualitative, you come up with the results, you imply the results, get some history, and then apply quantitative, or sometimes apply quantitative and qualitative at the same time and compare them all the time. This is on the macro level. On the micro level, what do we have? On the micro level, we have data-driven decisions, Data-driven decisions, they require constant quality control of your parameters. It's like this. If I want to, let's say, for example, on quantitative method, if I want to use a dampening factor on the micro level, a dampening factor, this factor, for example, can range from 5% to 50%. Which do I use? You use the one that actually gets you the most stable tracking signal, that's to say consistency, and the one that actually gives you the minimum error or the minimum bias. This is on the micro level. So on the macro level, we have qualitative with quantitative. On the micro level, we have what? We have a quality control, quality control in terms of bias and discrepancy about the data. This is the big picture of forecasting. The quality control in context forecasting is a combination of accuracy and precision check, as we said before. Like, where do we have what? Where do we have the qualitative making method? It's a decision-making method that helps you incorporate the opinion of, remember, qualitative, the opinion of experts, the opinion of the market, the opinion of executives, and even rumors. You can all include them all from a qualitative perspective, translate them into quantities, and actually enhance your decision and your forecasting as well. So if we look in retrospect, if you look at the skills that are needed nowadays, whether in analytics or otherwise, I believe this was done by McKinsey.
McKinsey.
So McKinsey and company, the skills reported to address reskilling, the reskilling of the workforce, the post-COVID-19 workforce. The most critical one you have here, critical thinking and decision making. This is first. Well, this is good news. Leadership and managing others goes without saying. Advanced data analysis and mathematical skills. We don't want to scare anybody. I mean, math is very objective, it's not subjective. And wow, project management came fourth. Well, not bad actually. It's not bad. So, what do you think?
Well, it's good for project managers. It's better for data analysis people. Okay, so I think you're gonna make more money than I would, because I don't.
Oh, I wish.
Okay. Unless we both go upstairs and do more leadership.
Well,
the leader gets it all.
yes.
Okay, and this is your last slide. Can you tell us, please, what this is?
This is ORE, the end.
ORE.
Yeah.
Okay.
Both in Chinese and Japanese. This is the kanji that shows the end.
Okay. Dr. Kebbe, thank you very much. Before we start question and answers, I'd like to show a very quick video on our next session. And Mustafa can put the link, please. Then we...
Hi everyone, this is Ahmed Majid, Certified Value Specialist and Value Engineering Licensed Trainer. We'll be talking to you about how to maximize the value of value engineering to deal with the pandemic challenge. Follow this interesting topic on Advisor webinar.
So, thank you very much, Dr. Kebbe. It has been, to me, a tough session, okay? I was not the best person in mathematics.
Well, I hope I haven't actually put anybody to bore. I'm known to, to put people to sleep. And I hope I haven't taken more than my time.
You already took more than your time, but there are still 160 people not sleeping. Or they might have slept and forgotten the system right now. So I believe Mustafa, some of our colleagues wanted to join. So by the time they join, I'm going to start with some of the questions. So here we have from Nabil Farhad Talib, what role can neuromarketing play in qualitative and quantitative and qualitative study?
Interesting question. Well, neuromarketing is like a rich source of both for both quantitative and qualitative models, whether we're talking descriptive, prescriptive, or predictive. Well, to put things in perspective, these technical terms, marketing or otherwise, they serve as techniques that are used in order to bring together the qualitative aspects of data with the quantitative aspect. We have two problems here. We have two main problems in such a hybrid, approach. The first problem is, what is the context of combining these two together? I mean, how do you combine them? I give you a very simple example. When I mentioned the matter of gender related to the matter of years of experience, we all know that in terms of gender, women are underpaid. I mean, this is the bottom line. They are underpaid. So a lady with the same amount of years of the same experience as a man will get paid less, I guess.
I think so.
Yeah. So in this case, the way that we brought these two together was to use a regression method that actually took into consideration a qualitative variable. In terms of neuromarketing and other methods like that, they are more inclined to be used, they give themselves to be used more in terms of heuristic approaches, like, for example, if you are talking neural networks are more compatible to actually use that data, to use that approach. But of course, we have many other methods.
Now, there's an interesting question from our friend Ahmed Mukhtar, one of our speakers as well. He's saying, why are forecasts of EAC in earned value management usually not accurate? Do you need to mix qualitative analysis with the time series method, for example?
Well, not necessarily qualitative, but let me tell you that the problem with these people is that they are stuck with typical and atypical. These are two extremes. These are two extremes. How many stops do you have within, within a project? Let's say a project goes like 7-8 months. Can't you have, for example, snapshots, 8 or 9 snapshots within? If you can, then obviously you can actually afford not to go to these extremes. You can use something in between, something which is more precise. This is the problem.
Okay. Another thing. One thing about earned value management, from my perspective, I'm an earned value management professional by ACE.
Yes.
And it is used mainly in the States for the cost-plus contracts imposed by the federal government. And one basic thing about them, they are as good as the model you use. Meaning, in many cases, they use models that are not that accurate. Okay? Like this activity will take 12 days, and they don't make any statistical accuracy thing about it. Okay? So when we use the quantitative methods, specifically Monte Carlo method, on this okay, we're back. So they don't use statistical methods like Monte Carlo simulation to check the accuracy, whether or not we're gonna finish in 282 days. So statistically, it shows like 5% or 10%. You're gonna finish in 282 days. So if you're using earned value data and forecasting on a model
that's already low quality.
Low quality.
Yes.
Okay. You will not get the good results you are looking. Yeah. What is Gigo? Okay. Now another question from our friend Nawaf Ahmadi. Thanks, Dr. Ibrahim, for such a subject, knowing that history, he's saying, repeat itself. Incidents are repeated in many cases that are similar to others. And considering the high probable risks in turbulent times, how can one maximize the chance of having realistic forecasts? Is the AI machine learning, is it the solution?
Well, this is a very good question, Pradeep. And yes, machine learning, or to be precise, deep learning or deep learning models are employed in that area, because deep learning models are unsupervised. What do you mean unsupervised? Unsupervised models in learning or machine learning models are models that do not need, and this is very important, they do not need history. Okay? What do they rely upon? They rely upon initial conditions. They start off with initial conditions, an iteration, a zero iteration approach that shows a great error. Then it learns from its error, and it validates against the facts. It validates against the facts and directly corrects itself. An example of that would be, for example, more into the classical, not machine learning, the spectral methods. Spectral methods are methods that, if anybody here is from the engineering background, partial differential equations that explain electrical and mechanical behaviors in systems. The display of these, equations, it actually explains these phenomena. So in order to be able to predict these phenomena, you need to solve these equations, these partial differential equations. The classical approach is to use the finite difference methods or the finite element methods. Whereas spectral methods have gained popularity over time only because two things. First of all, they are global methods. What do we mean by global methods? Global methods means that these are methods that look at the problem in one shot. They have a very wide angle of looking at the problem on one hand. On the other hand, these global methods, they, especially for example, the one I mentioned now, the spectral method, they go to the solution exponentially. So like machine learning, these methods, and machine learning is actually based on some of these methods, machine learning actually, or these methods, they go to the solution very fast, which means that they don't need much of a sprint. They don't need much of a starting run in order to get you results. So this is indeed a very good approach to such problems.
Okay. Somebody joined us. Can you please turn on your mic and your camera on?
Hello.
Hello.
Hello, everyone.
How are you? Hello. How are you, my friend?
Thank you. I'm fine, Dr. Adra. Thank you very much.
You're welcome, Ahmed. Okay, can you tell everybody who you are, please? Introduce yourself.
I'm actually the managing director of Drina Consulting, which is a project management consulting firm based in Tunisia. I recently joined the advisors network, and I'm really pleased and humbled with this partnership.
You are most welcome. We are happy to have you as part of our group. You're welcome.
First of all, I would like to thank Dr. Ibrahim for this insightful talk. I also would like to thank you, Dr. Adra, for creating and maintaining this positive dynamic and keeping this momentum and this opportunity for learning and sharing ideas. And we've been discussing through the chat regarding how we build risk models. And I have a question for Dr. Ibrahim. Actually, the question is, when building predictive models, we usually assume that studying the past and let's say deriving its trends will allow us to precisely forecast the future. And when doing this, and when ignoring unpredictable events or black swans, as described by Nassim Taleb, usually this leads to major setbacks like financial crisis in 2008 or the pandemic, the COVID-19 pandemic. So the question is how to avoid such modelization pitfalls. Can we rather rely on quantitative models to identify our business or project weaknesses and build robustness or anti-fragilities in our models.
Okay. Okay. Well, can everybody hear me? Okay. So, interesting question. Well, as I said before, there are 2 points I'm going to repeat. First of all, quantitative methods are as good as the qualitative assumptions that they are built upon. This is one. 2, I said before that if you can afford to erase or ignore or isolate, the correct term is to isolate that spike that we talked about, then by all means you can go along with quantitative. But history has taught us something. When I talked about cycles, business cycles, I said that the stock markets, they have passed through much turbulence in 2008 and before that in 1986 and before that in 1929. Well, this is why, for example, in the stock markets, the American stock markets, it's very hard to look or to detect business cycles. This is, however, something that you can do in the British stock market. Because British stock markets, they have shorter cycles on one hand. On the other hand, they have much stable ones. So they might say, well, in the 1940s, we had a large disturbance. Well, yes, okay. But the point is that, for example, in 1986, what happened was the tax reforms that Ronald Reagan did in his time, the tax reforms, and the entrance of technology companies into the stock market. So these are 2, if you want, black swans that came together in the pond. Then you had the 2008 events, and way before that you had 1929. Obviously, that shows that business cycles are not reliable, which means in turn that quantitative methods are not by themselves reliable. You need to actually work on global methods that use qualitative, qualitative approaches. Okay. So what do I mean by qualitative approach in this context? What I mean is, for example, you use the opinion of experts. Okay, and many experts have actually seen the 2008 crunch. They have seen it. We should have, this is the point, we should have listened to these people. So obviously there was a political resistance to the qualitative input of these people. That was what went wrong. So this is a lack of leadership. So I would guess that taking these qualitative approaches, okay, as a basis for our quantitative ones, this is the best way to actually avoid these problems.
Okay.
Yeah, thank you.
Thank you, my friend. Thank you for joining us tonight. And by this question, I'd like to end tonight's session. We are very happy and pleased to have this discussion about forecasting with Dr. Kebbe. Thank you very much. I think it's deep and highly technical.
Yes.
Okay. So until next Wednesday, stay safe. And we're gonna talk about value engineering. Stay tuned because we have lots of activities, lots of excellent speakers coming up in July, August, and September, inshallah. Good night, everybody.
Good night.